Here we are back with exercise 5 and 6 in section G.1. So hopefully you've done these. I'm going to do exercise 5A and then give you a little moment to pause it if you're stuck and you just need a hint. So let's see. We want to see, is the result positive, negative, or zero? We don't actually have to evaluate it, but you could. So negative 2 to the power negative 3. Well, that negative 3 exponent means this is going to go in the bottom of the fraction. We're going to do 1 over negative 2 to the power positive 3 now. So what is negative 2 to the positive 3? Well, it means 1 over negative 2 times negative 2 times negative 2 and 3 times, and two of these are going to pair up and make a positive. Negative 2 times negative 2 is positive 4. So this is the same as 1 over positive 4 times negative 2. And then that odd one out there is I'm going to take this positive number and make it negative. So you get 1 over negative 8, which is a negative number. So that's the approach for these. Now's your time to pause it to try the rest if you were stuck. Okay, so negative 4 to the power 0, well, that just means 1. Anything to the power 0 is 1, and 1 is a positive number. How about negative 2 to the negative 3? That means negative, well, it comes out to be negative 8, just like the denominator of this fraction did here. And so that is negative. How about this one? Negative, I'm going to leave this negative on the outside. And then negative 2 to the power 1000 means negative 2 times negative 2 times negative 2 times negative 2 1,000 times. So what is going to happen with those 1,000 copies of negative 2? Well, let's see. 2 of these are going to cancel out, like to make a, not completely cancel out, but just turn into a positive number. A negative times a negative is positive. The next 2 are going to make a positive number. And 1,000 is an even number, right? So that means you're going to be able to pair these up all the way up into 500 pairs of positive numbers. So all of that is going to turn into 500 pairs of positive numbers. Like, it's basically going to be 4 to the power 500. So there's still the negative on the outside, so it's negative 4, whoops, to the power 500. And that's going to be a negative number, because 4 to the power 500 is going to be negative. So this is a negative gargantuan number. So it's super negative. Okay, so how about negative 2 to the negative 4? Well, you could write this as 1 over negative 2 to the positive 4th power using the definition. And 4 is an even number, so you're going to have all those negative numbers are going to pair up. So there's going to be a negative 2 times negative 2 is one pair that makes a positive number, and then another negative 2 times negative 2 is another pair. So those are going to give you a positive number at the end. And how about this last one? How about negative 3 to the negative 3? Let's deal with that first. I'm going to leave that negative on the outside alone. And then we're just going to look at negative 3 times negative 3 times negative 3. And that's going, well, two of these are going to pair up to make positive 9. So you have 9 times negative 3, which that odd one out here leaves you with an extra negative factor at the end, which makes that part be negative 27. So we still have negative 27. And the opposite of negative 27 is positive 27. So this ends up being positive. Okay, so that's that one. Let's look at exercise 6. So yeah, this is just getting a lot of practice. And getting lots of practice with this kind of thing is super important because we're going to be using these exponent rules and this definition of negative exponents kind of throughout most of the rest of the class. So the more practice you get with it, the better. And if you don't get practice with it, you're going to end up kind of falling behind and not knowing what's going on, and it's going to be no fun for anybody. So anyways, let's look at a to the negative 3 first. So there's a 2 times a to the negative 3. That a to the negative 3 means 1 over a to the 3. And then that times a to the 8th. And you can think of 2 as just 2 over 1. And a to the 8th, the same way you can think of as a to the 8th divided by 1. Like so. And then you can just multiply them together. So you got 2 times a to the 8th is 2a to the 8th divided by a cubed. And then you can subtract those exponents to get 2a to the 5th. And by the way, you might have done this another way. You might have done just 2 times a to the negative 3 plus 8 using the exponent rule that says just add up the exponents. And if you do that, you can kind of go straight to this method. And that is totally fine. The more ways you have to solve these problems, the better you're going to be. If you can do these problems in 2 different ways, then that's even better than doing 2 different problems. It's going to build confidence and help you understand why the rules work. So anyways, I'm going to do that method with this one. Just using the shortcut exponent rule, which says you can add the negative 4 and the negative 3 instead of using the definition of negative exponents. So using that shortcut rule, this is going to become 5 to the negative 4 plus negative 3. And negative 4 plus negative 3 is negative 7. So that's 5 to the negative 7. And if we want to write this without negative exponents, that would be 1 over 5 to the 7. You could also, like what I was saying before, you could also write this as 1 over 5 to the 4, different method here, times 1 over 5 to the 3, and maybe skipping a few steps that should lead you to that. Okay, let's look at this one. I want to do this one using a shortcut rule. If you have p to a power divided by p to a power, you can subtract those. So I'm going to write this as p to the, well, sorry, before I do that, let's consider the 3. What do we do with this 3? We didn't really have other factors combined here. You can sort of ignore that. You can just think of it as 1/3 by itself, and then deal with the p to the -7 over p to the -4. And if you know how to deal with this part, you can deal with the 1/3 later. And so that's going to become 1/3 times p to the -7 minus -4. Because when you have exponents in the top and bottom of a fraction with the same base of p, you subtract the exponents. So that will be p to the -7 minus -4. And that gives you -7 plus 4, which gives you 1/3 p to the -3. And p to the -3 is 1 over p to the 3. And then, so we're just multiplying the 1/3 by that, which gives you 1 times 1 in the top, and 3 times p to the 3 in the bottom. Okay, so if you don't want to like deal with actually splitting this up, another way to think of this is just that 3 does not have a negative exponent on it. It doesn't have any exponent on it. So as you're messing around with the p's and the negative exponents and combining that, the 3's kind of just hanging out there. It's in the same place it was in the beginning. So an extra factor like that, you can just kind of leave it alone, as long as it doesn't have any exponents applied to it. So let's look at this one. We got 7 to the -2, and then that to the power 5. So if you have a power to a power, you can multiply those powers. So that would become 7 to the -2 times 5. -2 times 5 is -10. If you want to write that without a negative exponent, the -10 exponent means 1 over 7 to the 10th power. So that's that. Okay, here, what you have is all multiplication. There's 4 times x to the -5, and then that times 5, and then that times x to the power 2. So if it's all multiplication going on here without any addition, you can just regroup and reorder it. Write this as 4 times 5 times x to the -5th times x to the power 2. And then you can just do the 4 times 5 is just 20. And then x to the -5 times x to the power 2, you can add those exponents, which comes out to be x to the -3. So you get 20 x to the -3 power, and then x to the -3 power is 1 over x to the power +3, and you can treat the 20 here as like just 20 over 1 if you're not sure how to multiply these. So you get 20 times 1, and 1 times x to the 3 is 20 over x to the power 3. Okay, things are starting to get pretty complicated here. So this is where you've probably got some wrong answers at this point, and that's okay. You're still learning the stuff. Most people, when I teach this stuff, struggle with problems like this the first time. So what I want to do is, there's different ways to approach it. I think it might help to just think of the parts with the 5s and the parts with the t's as separate, and do it as like 5 to the 6 over 5 to the -2, and then have that times the fraction t to the 0 over t to the -1. That's the same thing as this. So that way you don't get confused by how they're being combined. And 5 to the 6 over 5 to the -2, you can subtract those exponents. So that would become 5 to the power 6 minus negative 2. 6 minus negative 2 is 8. But then let's deal with this other part here. 0 minus negative 1 becomes t to the 0 minus negative 1. And 6 minus negative 2 is 8, so that's 5 to the power 8, and t to the power 1. Or just t. So we're basically treating the part with the 5s and the parts with the t's separately. Another way to think about this that I think might help is you could always take a negative exponent and move it to the other side of the fraction, is another sort of shortcut rule here, which is I would like to think of this as just 5 to the 6, and then that 5 to the negative 2, you can move it to the top and it becomes a positive 2. Like that. And then there's a t to the 0, and then t to the negative 1, move it to the top of the fraction, and it becomes a positive 1. That's another sort of shortcut rule that makes these a lot easier. But if you don't know as many shortcut rules, then that's okay. You can just deal with the more basic rules, and it just might take a few more steps, and that's fine. All right. Looking at G here, we have 3 factors being multiplied. And then that is now raised to the power negative 2. So I'm just going to take each of those 3 factors and raise each of them to the power negative 2. Using rule number 4, I think that was. Okay, so the 3 to the negative 2, if I want to write that without a negative exponent, I'm going to turn that into 1 over 3 to the power positive 2. X to the negative 2 to the power negative 2, a power to a power like that, you multiply those. So that's going to become x to the negative 2 times negative 2. And then you have y, same deal, to the power 3 times negative 2. So, and these ones that are not fractions, and you kind of want to think of those as just divided by 1. So you can see that they just end up in the top of the whole fraction when you multiply this all together. So you have this 1 from over here times x to the 4th, because that's negative 2 times negative 2. So 1 times x to the 4th times y to the negative 6 divided by 3 squared, which is just 9. And then this y to the negative 6 here, you could write that as 1 over y to the 6th, or I'm just going to use the shortcut rule I was talking about here and just move it to the other side of the fraction and write this as just x to the 4th over 9 y to the positive 6th. Okay, so that's that one. Let's look at this one. This is another pretty mean one. So what I'm going to do is do 6 to the power negative 2, and then a to the power 3 to the power negative 2, and then b squared to the power negative 2. So just raising each of the parts to the power negative 2 there. And then I'm going to simplify each of these. A to the power negative 6, that's 3 times negative 2. 2 times negative 2 is negative 4. So that's going to leave you with all of these are negative. I'm going to use sort of that shortcut rule. You could do this a long way too, but the shortcut rule is basically just if you have something in a fraction with a negative exponent, just move it to the other side. So that b to the negative 4 is going to become b to the 4th in the top. 6 to the negative 2 is going to become 6 to the positive 2 in the bottom. A to the negative 6 in the top will move to the bottom and become a to the positive 6. So this, you could also write it as just b to the 4th over 36a to the 6th. All right, here is the worst one. First, I'm just going to deal with the h to the 4 to the power negative 2. So that's a power to a power, so we're just going to multiply them and get 5h to the negative 3 times h to the negative 8. That's all divided by 6 times h to the negative 5. And maybe let's combine these first. The h to the negative 3 times h to the negative 8 is negative 11. And so there's a few ways you could approach this. You could just do negative 11 minus negative 5 and make it be in the top, or you could let's see, move the h to the 5th to the top and the h to the 11 to the bottom. I'm going to do it that way. Like so. And then you could basically just cancel out 5 copies of h from the top and bottom. I think is a really good way to think about this. That's going to leave you with 6h to the 6 in the bottom, because if 5 of these 11 copies of h cancel out, then there's 6 copies remaining. There's other ways to do it. If you did this a different way, that's great. And if you did this a different way and didn't get these answers, then a good thing to do would be to hop into office hours, and I can look at your work in the office hours, or go to the tutoring hours and with your tutor, Kimia or Sarah or whoever it is in your class, and you can show them your work and see what you're doing wrong. Because it is good to do these in a way that you understand, but if you're making mistakes, you want to figure out what those mistakes are. All right, so that's G.1. My recommendation is to do some of the some of the G.1 homework before going into G.2, because G.2 relies on having a little bit of skill with these G.1 concepts. It is going to build on itself pretty fast here. So anyways, good luck with that homework, and I'll talk to you later.